Hi, here on the workbench today is a component tester sent in from FNIRSI. The model number is LCR-P1. On the product box it says transistor tester, but it can actually test more than just transistors. Besides testing transistors, these kind of devices can also test MOSFETs, resistors, capacitors, and inductors. This LCR meter has some additional capabilities, such as measuring Zener diodes and even decoding IR transmitter signals. So component testers are pretty useful, especially for hobbyists. Of course, a component tester is by no means a replacement for dedicated equipment like a multimeter or an LCR meter. But everyone into electronics should have one in my opinion, as I do find it quite useful when doing repairs. I actually bought one of these ATmega 328 based component testers 7-8 years ago, and I've been using it once in a while, and it was not bad. Of course, this one could not measure Zener diodes, nor could it do IR decoding. So in this video, I'm going to test out this FNIRSI LCR-P1 and see how well it compares to the good old T4. The FNIRSI LCR-P1 is quite compact here, as you can see, compared to the T4. It has a 1.44-inch color display and is powered by a built-in 300 mAh LiPo battery. I guess I'll start testing some of its unique features first. As mentioned before, it is capable of testing Zener diodes. According to the manual, it can test reverse breakdown voltage up to 30 volts. So obviously we have a step-up DC to DC converter built in when Zener diode mode is enabled. Let's give it a try. But of course, first let's remove the screen protector. We have a ZIF socket in place here. Most of the time you can just directly plug the components in. Of course, if you want to test surface-mounted components, you can always use the built-in adapter here. Now I do wish you don't have to swap out the adapter. It would be nice if you can just simply plug into the ZIF socket here without having to remove the socket itself. But anyway, this one will come in handy if you are testing the surface components, which I'll show you a little bit later. The component tester also comes with these leads, and you can use them to grab onto your components for testing. Now I do wish these are actually mounted on a socket, so you don't have to plug these in individually. But anyway, let's give it a try here. By the way, to measure Zener diodes, the only socket positions you can use are these three you can see here, labeled as cathode, anode, anode. So you'll have to use these three positions. Anyway, let's put in a Zener diode. And let's see what we get. So you press test, it powers on, and then you press the Zener diode. Of course, right now we're just entering the Zener diode mode. Let's press test again. And you can see right now we are actually reversed. You can see here it indicates that you should place it the other way around, as right now it's just a standard diode. So let's swap these two leads. And let's test again. And you can see we're measuring 14.82 volts. The Zener diode we're measuring here is a 1N4744, which is a 15 volts Zener diode, and that measurement result was pretty close. Let's do it again. So let me power it on, and let's do this. Yeah, you can see it's 14.61, so that's pretty close. Let's try another Zener diode. Here I have one I think is around 5 volts. Let's give it a try here. And this one we can probably put it directly in. Wrong polarity again. Yep, this one is 4.44 volts, which is close enough. This function is actually quite useful, as you can't test Zener diodes easily with a typical multimeter due to the insufficient output voltage in diode mode. You can also use this mode to test high voltage diodes like those used in a microwave oven. Those diodes have forward voltage drops close to 10 volts. Of course, the tester would think it's a Zener diode due to the high forward voltage, so let's give that a try. Now I'm going to put back these leads. And by the way, it does stay on for about half a minute, which is sufficient for most of the testing. So let's put this in again, and let's get our micro diode. So here's the diode I'm looking at here. So let's turn on. And I probably have to swap it. Alright. Yeah, you can see we have now measured a voltage drop of 8.26 volts. So everything's working as expected. The next function that is unique to this FNIRSI LCR-P1 is the IR decoding capability. According to the manual, the IR sensor is located in this corner here, which it looks like a speaker, but it's not. It's actually the IR sensor. So let's try with a few remote controls. Let me power it on again. And to test IR, you can see we have these two positions. One is the transistor testing, which is right now what we're using for testing components, and the other one is for IR decoding. So let's change it to IR decoding, and let's give it a try here. So here I have a remote control. Yeah, you can see, actually it's quite broad. It's not really sensitive to where the remote control is, but you can see here I'm pressing different keys, and you can get the different decoded commands here. So that's nice. Let's try another remote control here. Yeah, you can see that the signals are getting decoded here. So let's zoom in. And this is what we got here. Now, while this IR decoding works with most of the remote controls, it doesn't work with some of the IR devices. For example, I have a IR keyboard here, you can see here, and this one, let's see if it works. No, it doesn't work, but IR is actually working correctly. I'm not sure if you can see the emitted IR here. So you can see that this one doesn't actually work with this IR decoder. It would be nice if it could just display the raw zeros and ones, but anyway, that's probably too much to ask. Nowadays, everyone tries to squeeze in more functionalities in their products in order to stand out. Adding an IR decoder seems to be an odd choice, as I can think of a lot of things to add before doing that. But it seems to be a rather clever choice, as all they need to add is just a IR diode. Everything else is done in the microcontroller. Now let's test a few more components. Let's start with some resistors. The first resistor I'm going to test is this 10K resistor, so let's just put it in. And power it up. Now I don't know why initially when it powers up it doesn't detect anything here, so we'll have to do it again. That's probably something we need to fix in the firmware here. So it did test out to be a 10K resistor, roughly 9.9. So let's actually test it with the component tester here. Let's try the same resistor with the T4 here. Yeah, you can see the T4 measures 9.96. And this one, when we initially power it on, it actually recognized the component without having to press the testing again. So that is actually very neat. Now I do think that actually the speed of this FNIRSI is a little bit slow. So let's actually try that again to see how fast it is compared to the T4 here. So let's see here. Yeah, you can see it's taking a little bit longer. Maybe it's comparable, but it does feel it's taking a little bit longer. But anyway, 9.93. So let's actually verify that with the unit key here. Of course, we're not going to verify every single measurement. Let's just do that to get a sense of how accurate everything is. So let's see here. I'm trying to not touch the leads. Yeah, so both of these component testers are a little bit out. You can see it's actually only 9.8, but regardless, that gives you a rough idea of the components you are measuring. According to the spec sheet, the FNIRSI LCR-P1 is capable of measuring resistance from 0.01 ohm all the way up to 50 mega ohm. Of course, at lower resistance, I would expect it will not be very accurate anymore. So let's actually take a look at the 0.1 ohm resistor here. So this is a 0.1 ohm resistor. It's very annoying every single time you have to press it again. yeah, you can see the value is 0.4 ohm, which is quite a bit out, which is to be expected, I suppose. Now let's take a look at here. Yeah, so the measurement between these two are actually quite comparable, but they're both off. Anyway, let's do a 100 ohm precision resistor here. $102 ohm. How about this one? 99.3. So you get an idea. Obviously, you can't use this to do precision measurement, but it does give you the ballpark of the resistance reading. Alright, one last one. This is a 1 meg ohm. Let's try it. Yep, actually that's pretty fast. So maybe the speed is actually quite comparable. Maybe I was just not patient here. So let's do this one. No problem. Now let's measure a few capacitors. The first one I'm going to measure is this 15 picofarads capacitor. Let's give it a try. According to the manual, actually the range is between 25 picofarads and 100 millifarads. So of course it's very annoying. Every single time you power it on, it actually doesn't recognize the component. Let's do it again. Yeah, FNIRSI gotta fix that one. Oh, maybe it's not actually, sorry, this is my bad, because this is a used one. It's not really clean. I guess the leads are not clean, so let's try different sockets here. It does take 5 or 6 seconds. This one says it's 62 microfarads. Oh no, that's not right at all. Hang on, this is only a 15 picofarads. It says 62 microfarads. What's going on here? Let's try clean the leads a little bit, as this one was bent quite a bit here. So let's try it again. I wonder if different socket positions make a difference here. So let's give it a try here. It does take quite a bit. Yeah, it's reading 12 picofarads. So this is actually okay. I'm not sure where it got that 60 microfarads reading. Let's try different sockets. Okay, maybe it was just the contact, but right now it's giving the correct reading here. So let's take a look at the other component tester. And we're not able to read that, so let's try different sockets. Still not able to read that. Okay. Yeah, so we're not able to read that with the T4, but this one is actually below the minimum capacitance it was supposed to be able to measure, so that's just something to pay attention to. And let's measure another one. As the capacitor gets larger, you can see it's taking actually longer. So this one is a 1 microfarad capacitor, and it looks just about right. And with the ESR of 2.45 ohms, I don't know if that is correct or not, but we can actually verify that with a LCR meter. Actually, let's do that. You can see that we're actually getting 1 microfarads, and the ESR is 3.2 ohms. We were measuring 2.5 ohm here, so that's actually not too far. Alright. So let's try this component tester. I may not be able to compare every single components between these two testers, otherwise it would take forever for me to do the video, but you get some idea here. Now this one is actually quite a bit off. As you can see, the ESR is 0.69 ohm, but the capacitance is actually a little bit lower as well. That just gives you an idea that these kind of meters are actually not really that accurate. Here I have a 15,000 microfarads or 15 millifarads capacitor. Let's give it a try. Let's see here. I wonder how long it will take before it produces the result. Is it able to measure it? Well, it's actually measured 14.5 millifarads with a 0.08 ohm ESR. So that actually may be in the ballpark. Let's actually give that a try. So it's 13 millifarads, a little bit out, and the ESR is 40 milliohm instead of 50 milliohm. So actually that is not that far off. Not bad at all. How about the T4? Let's look at that. Again, the T4 is taking its time as well, which is somewhat to be expected because it's a large capacitor here. Yeah, so the ESR on this T4 is way off, but the capacitance measured is actually pretty close. Anyway, that's just some comparison between these two component testers. Now let's take a look at the inductor. This one is a 221, which is a 220 microhenry inductor, so let's give it a go. Okay, not bad. It says 229 microhenry. So let's take a look at the other one. Yeah, very similar results. While I was looking through the specs, I noticed that this one also can be used to test batteries, which is very unique. Let's give it a try. Excuse me for the contraption here. I'm going to measure this battery. Of course, the first time, again, you can't detect anything. Come on. Wow. It certainly is taking a long time. Obviously, you wouldn't be using this as your voltmeter, but let's see if you can actually... Yep. Wow, okay, it did figure out it's a battery, but you can see here the battery voltage is 852 millivolts. That's clearly not correct. So let's actually take a look at what the voltage is. So the battery here is 1.2 volts. So yeah, that one was quite a bit off. You can see here. I'm actually not sure why it bothers to include this functionality, as the measurement is painfully slow and the result is inaccurate. Anyone into electronics would for sure have at least one multimeter lying around. Now, I suppose you could use this to check lithium-ion supercapacitors, but again, the voltage accuracy is pretty poor, so you can't really trust the readings here. Let's measure a few diodes and LEDs. Of course, we had measured Zener diodes before, but let's try a regular one. Yep, no problem. And by the way, it is taking a little bit long. Depends on the component type you are using here. So the diode is not particularly fast. By the way, I have tested all these with the other component tester as well, so I'm not going to show you here. This is a red LED. Yeah, you can see that the testing speed is not that fast. It blinked quite a few times, and it's 1.72 volts for drop voltage. So let's actually take a look at the behavior of this other component tester. So again, I'm going to put this in. You can see that this component tester is a little bit faster than the other one, but the measurement results are quite similar. Of course, the capacitance here is way off. I think this is 1 picofarads, this one is 18 picofarads. You just have to take these readings with a grain of salt. Anyway, let's now take a look at some of the active components. So the first one is a 2N7000, that's a MOSFET. And let's take a look here. I wish they fixed this in a firmware upgrade, as this is actually very annoying. Yeah, no problem. And you can see this is an N-channel MOSFET, and the transition voltage is actually quite comparable to what is specified in the datasheet. Alright, let's try a few more. Yeah, this is indeed an NPN transistor. This is a, let's see what it is. It's a tip 41C. And let's do a PNP here. So this is a tip 42C. Yeah, you can see no problem at all. How about this one? This is, I'm not sure what it is. It's probably another MOSFET. Let's give it a go. Yeah, again, there's another N-channel MOSFET. Try another one. Another N-channel MOSFET. The P1 also is supposed to be able to measure SCRs, or silicon-controlled rectifiers. Now, this one here is a BTW69-600. So let's take a look. No, it is measuring as a resistor. I don't think it's able to measure that. Let's change to different sockets here, see if it makes a difference. No, it can't measure that. And let's try the T4. I don't think the T4 can measure SCR either. Nope, T4 gives the same reading. So I'm not sure why it's not able to detect this. As I tested this SCR earlier, this is actually a good one. So not sure why. As mentioned earlier, you have this interchangeable adapters you can use to test SMT components. So let's give that a try. And I should just be able to lift this. Yep. And you can see we have a key here. And we also have a key here, so we can plug it in. And let's give it a go. Alright, let's just test a few. So let's start it. First one I'm going to test is, let's just say this resistor. Probably need to press it down a little bit. Yeah, no problem. It's a 305, so that's 3 mega ohm. Now let's test a diode. Yeah, no problem. And how about a transistor here? And this is tiny, so we need to make sure that it's positioned correctly here. I think it's okay. Okay, let me press it down. Yep, it is a PNP transistor. So this is definitely useful when you are trying to figure out what the SMD components are, because sometimes the markings are not clear and it would be difficult without a component tester to figure out the component. Anyway, enough testing. I think it's time for us to open it up and take a look inside. Now, I'm not expecting too much going on here because, as you can see from the other component tester, it's really just a microcontroller. Of course, this one probably has a DC to DC converter because of its ability to test Zener diodes. So that's pretty much what I expected here. And you can see on this side we have a 300 milliamp hour battery, then we have by the look of it, a charging controller chip, and also a DC to DC converter chip that is used to generate the high voltage used for the Zener diode testing. And here's the buzzer. That's pretty much all there is on this side. Let's take a look at the other side. On this side we have a microcontroller. You can see here, unfortunately, the markings have been etched off, so we don't know exactly which one they're using here. And here we have a USB controller by the look of it. And up here, again, that section is for the DC-DC converter. And here we do have a relay that is for switching the input. And you do hear it clicking when you press the component test button. And here we also have this IR receiver for decoding the IR signal. Overall, the layout is quite clean and the construction is quite neat. And that's pretty much all I wanted to cover in this video. The LCR-P1 from FNIRSI is actually quite decent, even though it has some problems here and there. Having the ability to test Zener diodes is definitely a plus. I hope you enjoyed this video. If you liked the video, please remember to give it a big thumbs up and don't forget to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.